Hello guys, we're back with our next lecture. In this lecture, let us go through the next topic, that is reflexive relations, guys. Okay, so reflexive relation is a topic, a continuation of diagonal relation. So basically in the last lecture we discussed the diagonal, right? Yes. So what is compulsory in diagonal, guys? So these diagonal elements should be there, that's it. So nothing more, nothing less, right? Yes. So reflexive is a friend of diagonal, so in that way you can assume. Okay, so what reflexive says is, so you can have the diagonal, like you should have the diagonal, and it says that you can have something extra also. I will agree for it, there is no issue for me. So that is what a reflexive will say. Got it? Okay, so what diagonal says, guys? Diagonal says that other than diagonal anything should not be there, and each and every diagonal element should be there. That is what diagonal relation will say. Whereas a reflexive will say diagonal should be there mandatorily, but rest of the slots you can have it, it's your wish. Okay, it's okay for me, there is no issue. So that is what reflexive will say. Got it? Yes guys, we'll be taking few examples, so don't worry guys. Okay, yes. Okay, so let us start. Reflexive relation. A relation R on a set A is said to be reflexive if A for all x belongs to A, x comma x belongs to R. Okay, 1 2 3 means 1 2 3. So if it is 1 2 3, so 1 1 2 2 3 3. These three items are mandatory, guys. So along with these three, rest items are optional. So they could be there, they could not be there, they don't care. That's it. Got it? Yes. So that's what I have written here. So 1 1 2 2 3 3 are mandatory and anything is optional. Okay. Yes. So now just to give me a second, I'll be taking something to cover so that we can just try to answer these things. Okay. Yes. Okay guys, in the next lecture we'll be discussing about irreflexive, so at that time also I will use the same table, guys. Okay, yes. So let us start. So what is a cross A, guys? So if you recall, A cross A is nothing but all possible combinations, right? Yes. So here if all combinations are there, indirectly diagonal is there, right? Yes. So if diagonal is there, we approve reflexive, so this is correct. Okay, so the second thing is a phi. Okay, so phi means what, guys? It is an empty set. So what is a mandatory in our case? These values are mandatory, but in phi nothing is there. Then why do we need that phi? So that is not reflexive. When it comes to 1 1 2 2 3 3, yes, these are the things which we want. Wow, exactly they are matching. Hence it is a true. 1 2 2 3 1 3. So 1 1 is not there, 2 2 is not there, 3 3 is not there. Why are you there? You can leave. It's not valid, right? Yes. 1 1 is there, 2 2 is there, 3 3 not there, not valid. Similarly 1 1 2 2 3 3. Okay, sorry. So 1 1 2 2 3 3, some additional is there. Okay, we approve it. These three people are important, that's it. Rest all can come, cannot come, no issue. Okay, so now the last one, 1 1 not there, 2 2 not there, 3 3 not there, invalid, right? Yes. So now you got an idea, right? So how exactly you can say that given relation is a reflexive or not, whether diagonal elements are there, not there. So just with that answer you can say whether it is reflexive or not. That's it. Got it? Yes. So now you got an idea, right? Yes. So now in examination, assume in that way. So they gave this set. Okay, and they are asking how many reflexive relations are possible. Okay, so what you will do now, guys? You start writing writing this and you will be solving it. So the best method for this is analyzing now itself, guys, because now we can analyze it, right? Yes. So the first thing that you should understand here is, so let me take a piece of paper. So for each and every type of relation, we will calculate a formula, guys. Okay, I don't know how many students will be interested in remembering the formula, but along with me, I am also not interested in remembering them, guys. I'll be remembering the method how we are solving it, and if it is a short method, I will follow that method itself. So that's what, even in this lectures we will be discussing some short tricks and methods to solve these things. Okay, yes. Okay, so basically how many relations are there, guys? So in total we are having n cross n, right? These are the number of elements. So if it is a 3 cross 3, so the result is a 9, right? So it is indirectly n square number of relations are there, right? Yes. So in total, what I am saying is how many relations are there. So basically how many this Cartesian product elements are there, to be clear. Okay, yes. So in total how many will be there, guys? So how much is our n value into the other n value? So it is n into m normally, but here both are n only, so it is nothing but n square, right? Okay, sorry for that. Okay, so it is nothing but n square. Okay, so let us continue. So at max we can have n square, right? Yes. So among these n square, how many elements are mandatory, guys? If you recall, we are having 1 2 3, we are having 1 2 3, and we need 1 1 2 2 3 3. So in total, what is our n number? That many n comma n pairs we want, right? Yes. So if it is 4, we need 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. So if it is n square, among them n are mandatory, right? Yes, and these n are nothing but those are diagonal guys, right? Yes, and these rest of the guys, that is nothing but n square minus n. So these guys are completely optional, right? Yes. So these guys are mandatory. So is there any combination or anything guys? No, right? So everyone should come. That's it. So means only one chance should come. That's it. But when it comes to here, so they could be present or they could be absent. So there are two chances here, right? Yes. So that is the reason why it is nothing but a 2 power n square minus 1. So it is a nothing but a 2 power n into n minus 1. Okay. So if you take a small example, okay. So assume that in examination they gave the value of n equal to 5. So this is a previous year gate question, guys. So if they gave n equal to 5 and they are asking what is the number of reflexive relations possible, it is a nothing but a 2 power of 5 into 4. That is nothing but 2 power 20. Got it? Yes. So that will be the answer. So it's a quite easy method, right? Yes. So the only concept is here diagonal are mandatory. So indirectly there is no chances of any kind of combinations. But when it comes to this n square minus n items, so there are two chances for each one of them. So if you take a small example here, so basically here it is 1 3, right? Yes. So 1 3 can either doesn't exist or it can exist. So it is having both possibilities. So that is the reason why I wrote 2 power. Okay. Yes. So now you got an idea, right? Yes. Okay. So this is the whole concept of a reflexive, guys. Okay, so what is reflexive? What does reflexive say? Reflexive says that whatever are the diagonal elements, I want them compulsorily, right? Yes. But when it comes to the other elements, they are optional. They could come, they could not come. No issue, right? Yes. Okay. So now I hope everyone got a clear idea on this. So in the next lecture, let us continue with, so the same problem I have solved in the same book also. Okay. Yes. And one more important thing is, so if you recall, what is the smallest reflexive relation, guys? So diagonal elements are mandatory, so indirectly diagonal will be the smallest. And what is the largest? Largest will be a cross a, because a cross a contains diagonal elements and including all others, right? Yes. So that also you can remember. Okay. Yes. So now I hope everyone got a clear idea about reflexive. So in the next lecture, let us continue with irreflexive. So basically reflexive opposite is irreflexive. That's it, right? Yes. Okay. So I hope everyone got a clear idea. So in the next lecture, let us continue with the next topic. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.